Today we are diving into one of the biggest DAX myths on the internet. Calculate is always faster than SUMX. You've probably heard it, maybe even repeated it yourself. Well, I tested it. And guess what? Reality is a lot messier than the myth. In some cases, Calculate wins. In others, SUMX absolutely smokes it. And in a few scenarios, neither makes sense. But we will get to that. Let's break it down using benchmarks, real DAX examples, and live query plans. Here, I have two tables displayed in Power BI. Both of them show exactly the same numbers. The totals match, the rows match, everything looks identical. At first glance, you'd think these two measures behind the table work the same way. But no, under the hood, DAX is about to surprise us. Let me show you the first measure. This one uses SUMX. Pretty simple. Filter the sales table to row where quantity is greater than 5, and then sums value over those rows. Nothing fancy. Now here's the second measure. This one uses Calculate. Same logic, same filter, same result. So basically, these two tables should perform similarly, right? Well, let's actually measure it. I'm turning on the performance analyzer. And now let's refresh the visuals. And here's the fun part. The table using SUMX took about 300 milliseconds to load. The table using Calculate took over 7,000 milliseconds. Yes, over 7 seconds. Same number, same logic, completely different performance. Now let's take this one level deeper, because performance analyzer is useful, but DAX Studio tells the real truth. First thing, I'm clearing the cache. And the result is over 10.5 seconds. So yeah, Calculate took it times again, clearing the cache again, and now running the same SUMX version. This one finishes in 900 milliseconds, under 1 second. So SUMX isn't just a bit faster, it's more than 10 times faster in this scenario. So what did we just learn? Even though the two measures return the exact same numbers, their execution plans are completely different. The Calculate version triggers context transition, dependency checks, filter propagation, evaluation of multiple internal queries. SUMX does something much simpler. Apply filter, iterate through resulting rows, sum the values. Done. When your filter logic breaks the storage engine pushdown, Calculate becomes overly complicated while SUMX stays direct and predictable. This is the specific case, the iterator is the faster option. So here is the big takeaway from the whole section. Calculate is not automatically faster. SUMX is not automatically slow. The winner depends entirely on how much work the storage engine can push down. If the filter is simple and the storage engine can optimize it, Calculate usually wins, but if the filter becomes more complex, even slightly, storage engine pushdown fails. Calculate starts doing a lot of internal gymnastics, and SUMX quietly outruns it. This is why performance in DAX is never about the function name, it's about what the engine is able or unable to optimize. Alright, let's go back to Power BI, because I want to show you something really interesting. I've created one more measure. Here it is. Notice the difference? This time I'm not wrapping the condition inside the filter. It's just a simple column filter directly inside Calculate. Let me drop this new measure into the table. And as expected, the results are still identical. So visually, everything looks the same. But performance? That's a whole other story. Let's run the performance analyzer again. Refreshing visuals. And now look at this. The SUMX table refreshes in 262 milliseconds. The Calculate no filter table refreshes in 229 milliseconds. So now, Calculate is slightly faster than SUMX, completely opposite of what we saw earlier. And all it took was removing one filter wrapper. Let's confirm this in DAX Studio. Opening DAX Studio, clearing the cache, now running Sales Calculate no filter. And the result is 900 milliseconds. So what's going on here? A tiny change, removing filter, completely transforms how the engine processes the query. When Calculate receives a simple condition like quantity bigger than 5, it can push this filter down directly into storage engine. And when the storage engine handles filtering plus aggregation in one pass, you get high performance. But as soon as you wrap the condition inside filter, the filter becomes row by row logic. Pushdown is no longer possible. The formula engine takes over, and performance drops dramatically. This is why the tiny difference is actually enormous for Vertipack engine. Same map, same results, completely different level of optimization. Now I go back to Power BI and drop in two new measures. The first one is calculate version with two conditions inside the filter, quantity above 5 and discount below 10%. The second one looks almost the same, except it uses SUMX with both conditions written directly as filters. Both measures return, of course, the same numbers. Now let's check how fast they are. I open Performance Analyzer, refresh the visuals. Here we go. Calculate version refreshes in around 215 milliseconds, SUMX version takes about 239 milliseconds. So Calculate is ahead, but only by a tiny bit. Next, I switch to DAX Studio, clear the cache again, because I want to make sure we are measuring the engine, not my laptop's memories. I run the Calculate measure, and it finishes in 257 milliseconds. Then I run SUMX version, 267 milliseconds. So again, Calculate is slightly faster, but the difference is small. Nothing like the dramatic results we saw earlier. And that's it for this segment. No summary here. We'll keep moving. I go back to Power BI and switch the measures again. First, I show the Calculate version. This time, Calculate includes a full filter block, the inside that filter I'm using related to check the product category. Then I reveal the SUMX version. It looks almost the same filters, same related, same conditions. Both return exactly the same values, which is good because if they didn't, this video would end very suddenly. Now, let's see how long they take. The Calculate version takes about 2.6 seconds. That's long enough for me to check my emails, make tea and rethink my life choices. The SUMX version finishes in about 201 milliseconds. So again, SUMX absolutely crashes Calculate in this scenario. Now I switch over to DAX Studio, clear the cache and start the tests again. I run the Calculate measure first, and it takes around 4.1 seconds. That's double the time from the Power BI. The formula engine is clearly not having a good day. I run the SUMX version, and it finishes in about 798 milliseconds. So the pattern repeats. In this scenario, SUMX handles the heavy lifting much more efficient than Calculate, wrapped inside filter with related. And that's it for this part. Let's keep going. I switch to the next pair of measures in Power BI. First up, the Calculate expensive version. Here I'm using Calculate, but inside I've stuffed a full SUMX, multiplying sales value by the unit price coming from the products table. And of course, we also keep quantity greater than 5 and discount smaller than 0.1 conditions. Then I swap to the SUM expensive. It filters the row first, same conditions, and then does the exact same multiplication inside the SUMX iterator. So logically, same result. Visually, same result. Emotionally, well, we'll see. Time to open Performance Analyzer again. I refresh the visuals, the numbers appear. Calculate version complete is in about 210 milliseconds. Not bad. It's like, yeah, I can do this, no problem. The SUMX version finishes in 189 milliseconds, a tiny bit faster. And now we jump back into DAX Studio for the real performance test. I clear the cache and the Calculate expensive measure, and this one takes about 287 milliseconds. Then I run the SUMX expensive measure, and it lands in 293 milliseconds. So in DAX Studio, they are basically tied. One wins in Power BI, the other wins in DAX Studio. Nobody wins emotionally. Alright, let's moving to the next part. So here is the big takeaway. Across all the tests, simple filters, no filters, complex conditions, related lookups, multiple predicates, and even expensive row-by-row calculations, the performance result was never about Calculate versus SUMX. It was always about what each function forces the engine to do behind the scenes. Whenever I use Calculate with a simple column filter, the storage engine could push the filter down efficiently, and performance was great. But the moment I wrap Calculate inside a filter expression, or use related in a row context, or added multiple predicates that couldn't be folded, Calculate lost all its theoretical advantages. It turned into heavy, FA-bound work, and SUMX was often faster. SUMX, on the other hand, is super predictable. It iterates the rows you give it, does the math, and moves on. It doesn't try to be clever. And sometimes that simplicity wins. And in the last test, when both measures were equally complex and equally expensive, they performed almost the same because they were doing almost the same thing internally. So the real message is, don't choose Calculate because you heard it's faster. Don't choose SUMX because you think Calculate is evil. choose the pattern that matches how the Vertipack engine can optimize your logic. In other words, performance depends on the shape of your filter logic, not on which DAX keyword you like more. And that's the truth behind all these surprising numbers on the slide.